Hi everyone, today we do Cambridge A-Level Further Mathematics, syllabus code 9231 for the Further Pure Paper 2. This is variant 3 from the May June 2025 series. We go for question 2. I've done question 1 already. So this is we call a hyperbolic function question. And we want to prove an identity, hyperbolic tangent squared and the hyperbolic secant squared, it will be equal to 1. So you want to use the definition using of the exponentials. Let's recall first about the definition, right? Sine or the hyperbolic sine, that is hyperbolic sine, that is the exponential x minus exponential of negative x divided by 2, and the hyperbolic cosine, that is the the exponential x plus the exponential of negative x over 2. So with these two, we know that the hyperbolic tangent is also the same. That is the sine over cosine of the hyperbolic functions, which will give us e to the x minus e to the negative x divided by e to the x plus e to the negative x. Okay, so we also know that the hyperbolic secant, that is also 1 over the hyperbolic cosine. Right, for the tangent or the left hand side, okay, left hand side, I'll write it as such. We know the tangent, hyperbolic tangent, is this expression, and I will square the whole thing, and then 1 over secant, the 1 over hyperbolic secant, 1 over hyperbolic cosine, there is 2 over e to the x plus e to the negative x. I will also square that, and you can see that on the bottom of the two expression or the two fraction, there will be uh, the same expression. So I'll combine the two fractions here and square it, and on the top we will have e to the x minus e to the negative x squared plus 2 squared, which is 4. I'm just gonna expand this square bracket here on the top, and also on the bottom I will expand that, and we can see that the 4 and the negative 2, we can do some simplification. We end up with this expression, which is the same on the numerator as well as the denominator, so this will just be equals to 1, and we have proven. Okay, we have proven this identity is true. And okay, so part B, we have given some parametric expressions here, and we want to find the length of C. Okay, so this is a parametric equation of C. And obviously, for the length, what we're gonna do is we have the integral of what we call dy dt squared plus dx dt squared, and in terms of t, this will be our integrand. And so let's find our or the derivatives in terms of t first. So dx dt, first of all, we will differentiate the natural log, which gives us 1 over hyperbolic cosine. And of course, we need to use the chain rule, and we multiply by the derivative of the hyperbolic cosine, which if you forget for whatever reason, you can refer back to the formula sheet. Hyperbolic cosine differentiates to become hyperbolic sine. Okay, so you can just multiply hyperbolic sine and we get a tangent or hyperbolic tangent in terms of t. Okay, now we have the derivative of y in terms of t, and we have an inverse tangent of hyperbolic sine function. So inverse tangent, where is the right? Inverse tangent should be up there. Yeah, inverse tangent will be this expression. So the x in our case, that will be the hyperbolic sine. So there will be 1 over 1 plus hyperbolic sine squared t, and of course we need to multiply by the derivative of the inside function, which is the hyperbolic sine, which gives us we multiply by a hyperbolic cosine. So let's do some simplification at the bottom here also, because we know that using this Pythagorean hyperbolic identity, we know that 1 plus hyperbolic sine squared, that is the hyperbolic cosine squared. So we're gonna, right, on the bottom, this expression, I'm going to change it to hyperbolic cosine squared on the bottom, and on the top we will have just a cosine, hyperbolic cosine. So this gives us a hyperbolic secant t. Okay, now we do the integral. Right. So the limits will be 0 to 1 as is specified to us in the question already. 0 to 1 dy dt squared, that is secant, hyperbolic secant squared, and dx dt squared, that is tangent, hyperbolic tangent squared in terms of t. So in the previous question, we've proven that the hyperbolic tangent squared added with the hyperbolic secant squared, that's just equals to 1. So the integration we're performing is actually can be simplified to integrate 1 from 0 to 1. So that's just 1. So the length of this curve is just 1. Okay, moving on. Oh, that's it. Right, that's it for question 2. So this is a hyperbolic question with some proving and also some calculus parts.